Yo guys, what's up, it's your boy Dipro here, and today we are back into a Minecraft video. Now, a couple of months ago, for April Fools, Reddit did something really interesting. It actually recreated an event that they did a couple of years prior. This was r/place. Basically, there was a really big canvas and every user could draw a pixel on that canvas, but the limitation was that you could only draw a pixel every 5 minutes or so. So communities and players had to come together in order to do some art on the canvas in hope of teamwork. And also they drew a lot of Among Us references everywhere. Yeah, that was nice. Anyway, in this video I wanted to recreate that behavior in vanilla Minecraft using Datapacks. And this is not only to, so you can add it to your server and, play with friends, but also so I can show you how the code works, and maybe you can learn something new about Datapacks. So I will show you first how this works. It's pretty straightforward actually. I have my palette right here of blocks, and I can actually do this in adventure mode. So, players can play in adventure mode on your server when they want to do this. This is the really big canvas, as you can see, and in order to place a block, I just need to place the block, and as you can see, it will go in the canvas. Afterwards, I will not be able to place any other blocks, and there will be a certain cooldown. So as you can see, once the cooldown is done, I'm able to place another block, and this is how I can draw art. And now, naturally, the cooldown is really low right now, because, I'm just doing demonstration purposes, but you can tweak this cooldown how much you want. And the other cool thing is, the cooldown will keep on ticking even when the player left the server. And that's a really important thing, because naturally a player could join the server and then leave and do something else and then come back when they are able to place a pixel again. Oh, also another thing, we managed to get my face, my little 8x8 face, on the canvas right at the last second, so that was really exciting. It wasn't my idea, it was really entirely community driven, but I gave a hand in the last couple of hours because it was truly amazing. So, thank you ever so much for that, we made history. So yeah, it's pretty straightforward, but you might say, okay Nico, how can I go ahead and place this on my server? Well, you can actually just do a function, rPlace.generate a canvas, so .generate place, and as you can see, if I can type correctly, yes, it will generate a canvas. It will lag a lot, but it will also generate a canvas. It will remove the previous one, as you can see, and will regenerate a brand new canvas, and as you can see, people will be able to play. So, as you might have understood, this is done using a custom datapack, and as you can see, the datapack is called r/place. So you just have to include this in your server or in your world, and you will be able to play right away by running this generate place function. So in this video I will show you how it is made, because it's pretty straightforward, but there are some slight challenges that you have to overcome, which are not that intuitive. So first of all, let's leave this world and let's go in single player and go to r/place. And as you can see, if I do edit, I can actually open the world folder. This is where all of the data packs and all of the, the actual world is stored. So I can open the world folder, and as you can see, I'm here. Now, if you go into the folder Datapacks, you will be able to paste my rPlace datapack in here when you create your world or when you upload it to the server. But now we're gonna go into this folder and I'm gonna show you how the datapack works. Now, a datapack is a way to execute command blocks without having to place command blocks in your world, which is what we need right now because I want this to work on any server. Before Datapacks, we used to use one command block creations, which were basically one single command block that spawned a bunch more command blocks, which was really interesting, but this is much more convenient. Now, I'm not gonna go in depth on how you structure a datapack, you can just see any other tutorial online for that, but I'm gonna quickly go into Visual Studio. Now, this is an IDE that, is gonna show you all of the functions and all of the contents of the datapack, and it's just much more convenient because the syntax of the different lines is done correctly, so I can go through the code pretty quickly and explain you what everything does. Now, first of all, we have our pack.mc meta file, which is just the description. Why do I always call it Datapack? I want. Why is it that? Okay, whatever. So now it's working. So this is just a description of the datapack, the format, which is basically the version. So you need this file in order for Minecraft to detect the datapack. Then inside of the data folder we have the namespaces. Now my custom namespace, where all of my custom code will go, is r_place. But we also want to modify some behavior of vanilla Minecraft. You may say, Nico, why are we modifying vanilla Minecraft? And I'm gonna show you in just a second. Now, if we go into the r_place namespace, as you can see, the only behavior we're adding are custom functions. Functions are basically pieces of command block code that can be executed all at once. So if we go right here, we have 6 different functions, and they may seem a little bit confusing to you just so seen this way, but don't worry, they're gonna make sense in just a moment. So here we have our custom code, but we also not only have the custom code, but also modifying some behavior from vanilla Minecraft. What behavior are we modifying? Well, we are modifying the tags. And specifically, we are modifying the block tags and the function tags. Okay, I don't know if you guys are familiar with block tags, but basically there is a really beautiful thing that you can do in Minecraft that makes life so much easier, and is that you can group blocks and do detection on that group of blocks. Okay, so let's say I want to detect if the block right here is Acacia log. I have to do execute if block in this position is an Acacia, if I can write. Yes, in Acacia log, and as you can see it's gonna say test passed because the block is Acacia. But if I wanna check if this block is not just an Acacia log, but it can be any log, how do I do it? Well, normally you would have to stack a bunch of commands together and check for every type of log. Well, thanks to tags, we don't actually have to do that. We can just do hashtag Minecraft logs, and as you can see this will check if there is any type of log in here. If there is concrete, it's gonna say test failed, and it's actually gonna place the block, which is not what I wanted. But if there is any other type of log, it's gonna say test passed. And now there are a bunch of vanilla tags in the game. These are all of the tags basically. So you have a bunch of tags, but for some reason concrete is not in one of these tags. So there is no way to group concrete blocks. And that's a shame because concrete blocks are exactly what we want to use for our canvas. So that's why we are altering the Minecraft vanilla behavior and we are adding a new tag, which is concrete tag. So that's what we're doing in here. We're just going into the blocks and we're adding a new tag. Now I didn't actually call this tag concrete, I called it palette. The reason I called it like that is so you can modify it and actually change the palette of your canvas, aka change what blocks can be placed on your canvas. So if we go in Visual Studio, we can actually read the palette.json file, and as you can see, it's pretty self-explanatory. We just have an array of values, and these are all of the blocks that are gonna be included in our tag. So now, at example, we can go here and we can check if this block is white concrete, and as you can see, in order to check if it's white concrete, not if blocks, if block is white concrete, we can just do hashtag Minecraft palette, and as you can see it's gonna work because our palette includes, if I can show it, because our palette includes white concrete. Okay, so that's the block tags explained, but we also have a folder with the function tags. Now, what are function tags? Well, it's actually surprisingly simple. Now, a function, as I said before, is a bunch of lines that can be executed all at once, whenever you want. Now, there are different ways to execute a function. You can just call that function. As you can see, I can do /function and call any function that I want. These are my 6 custom functions. So as you can see, I can call rPlace and it's gonna regenerate the canvas and remove the last one. So I invoked this function and the code inside the function has been run. What is that? Wait, what? What is happening? Did I just generate the Farlands? No, wait, what is this? No, see, wait, what? Wait, this is a super flat world. Why is it started spawning terrain? Okay, in my defense, this was a 1.18.2 world, and I loaded it in 1.18.1, but I didn't think it would break. I mean, it's a minor version change. Whoa. Okay, I mean, I generated with the custom settings, which I think were added in 1.18.2. So, okay, I never had Minecraft break like this. This is pretty exciting. But I mean, this is unrelated to the video. I have no idea how this broke. But yeah, probably tried to generate more chunks, and it doesn't know that this is a super flat world. Okay, that's really exciting. Okay, I wanna break it even more now. I mean, I know I'm getting sidetracked, but what the? How did that tree spawn here? I'm so confused. Oh, you know, it's probably because of the deep cave stuff. I'm so lost for words right now. I have no idea what is happening. Wait, does this go all the way to yeah, it goes all the way to negative because it's in. I'm so confused. Oh, this is gonna generate a lot of lag. Oh yeah, this is definitely gonna hurt my computer so much. Okay, well, this is beautiful though. Look at this. There is the super flat scenario, and then it just collides with generated terrain. Okay, this has nothing to do with the video. I'm sorry. Actually, just move away. Let's go back to 0, 0 in generated land. Oh my gosh, I don't want to look at that. I'm scared. Okay, I got sidetracked. What were we saying? Yes, I was saying functions can be executed when you call them, but they can also be executed on events, so they can be executed when something happens. Now, like in any engine or framework, there are two main events. There are functions that get executed on initialization, which means they only get executed once when you load the data pack, and then there are functions that get executed repeatedly, so every single frame, which in Minecraft means every single tick. So that's why we need the function tags. The function tags basically tell which functions need to be executed every tick, and which functions need to be executed only at initialization, and which functions don't need to be executed at all because I'm gonna call them manually. So that's exactly what we're doing right here. We are defining two different tags, which are function tags. I'm gonna open them with Visual Studio. So as you can see, these are the two function tags, and I'm basically saying that all of the functions into this array right here should be executed as soon as my data pack loads. And in this case, I'm only placing one function, which is rPlace column load. So this means that all of the code right here will get executed as soon as I start the data pack. So if I do here say hi, and then I go back into Minecraft and I do reload, as you can see it's gonna say hi, because it's executed this code as soon as the data pack loaded. And then we have this other tag, which is tick, which basically will execute the code every single tick. So all of the code right here, we are executing every single tick. So if I say hi right here and I reload the data pack, it's gonna start spamming hi all the way. Now, one thing I noticed is that in the tick function, we're actually always calling other functions. So in order to make our code cleaner, we could actually remove this tick function right here and just put all of the functions that we wanna call inside this array. This would actually make more sense. So let's just take these functions right here and let's put them in the array. So we're just basically saying that all of the code right here, all of the functions right here should get executed every tick, which is basically what's happening. Okay, there you go, and now we don't actually need this tick function, so we can just move it to trash. There you go, and now as you can see, Minecraft, every single tick will execute these three functions, which are doing three different things. One of them is checking for the player cooldown, this one is actually drawing on the canvas, and this one is detecting when the player has, clicked and placed any block. Okay, great, and that's the tags done, and now the code should keep working, hopefully. Let's double check that I didn't break everything in the world, so let's just place a block, and yeah, there you go, it works. Okay, so now the only thing left to explain is the code itself, as you can see. So we explained all of this part right here, where we modified the custom Minecraft tags behavior. Now we're gonna actually go into the functions and explain how this behavior and this logic works. Okay, now first of all we have the load function, which is basically doing a bunch of stuff. It's adding a lot of scoreboards. Now why do we need all of these scoreboards? They're gonna come in handy later, but we just need to define all of them. They are mostly needed to know if a user has placed a block, and also if they are on cooldown or not. So we are defining all of these scoreboards. We're also defining a score, which is gonna be the cooldown value. So from here you can actually change the amount of cooldown that the player will get. Right now it's at 100, which is basically, 100 ticks, and in every second there are 20 ticks, so this is why the cooldown is on 5 seconds. But I can actually put this to 200, and now the cooldown will be on 10 seconds. If I reload the data pack and I place a block, I will have a 10 seconds cooldown instead. So all this code is doing is it's initializing the scoreboards, but we are gonna know what each of these scoreboards does in the future. So now let's start looking at the code that actually gets executed every tick. And first of all, let's start looking at how we actually detect that a user has placed a block. Now this is actually pretty tricky, and it's actually harder than I thought, and it's a big problem. Now for some reason in Minecraft there is no way to detect if a player has placed a block. You may say, Nico, no, you're dumb. You can do it with scoreboards. You can just do scoreboard objective add, place the block, and then add a criteria. And the criteria could be Minecraft.used, Minecraft, I don't know, what blocks do we want to place? Acacia log, okay? Now this scoreboard right here will detect every time I placed an acacia log. So I can do place block, there you go. And if I place an acacia log, I'm gonna start getting a score, as you can see. So now this is really fun. The problem is there is no way to generalize this. You can only detect if you placed a specific block, but you cannot detect if you placed any block at all. As you can see, if I do this with any other block, it's not gonna work. So naturally I wanna make it so I can place multiple blocks in my palette. I don't want to only place one single block. So how do I get around this problem? And the way to get around this problem is by defining a scoreboard for every single block in the palette that I wanna place. And this is really unfortunate, but it has to be done. So as you can see right here in the selected code in the load function, we're actually adding a scoreboard for every single block we want in the palette. Now if you want to add a new block to the palette, you can just add a new score here and change this to, I don't know, I think we did every single type of concrete, so you can do white wool, and you can call this white wool placed. And then you can go into the palette.json and also add it here, so the player is able to place the block. But now we don't want to do that, so let's go back here and let's remove this line. So okay, great, these scoreboards are gonna detect every time a player has placed a certain block. And then we have this placed objective, which is actually gonna put all of these values together into a single scoreboard. And this gets done in the placeDetectTick function. So as you can see right here, we are resetting the value of placed, so we're just resetting this value. And then for every player, we are taking the score of the specific scoreboard, so the scoreboard for when they place the red block, and we are adding it to the placed score. So basically this scoreboard right here, placed, will have a value every time you place any of these blocks. And then right after, we are resetting all of the partial scores, so that only this one remains. So now I know this is really confusing, but basically what this code is gonna do is it's gonna take the placed scoreboard and will add a value of 1 every time you place any of these blocks. And then it will reset it next tick, because if you remember, this code gets executed every single tick, so 20 times a second. Now, before actually resetting the score, we are gonna check if the score is greater than 1, so if the player has placed any blocks. And if the player did, we're actually gonna do 2 different things. We're gonna give them a tag that is gonna indicate that they are in cooldown, and we're also gonna update their last place value to this value right here. So now what does this actually do? And this is another confusing part, but I think this is the best way to do this. I'm gonna show you exactly what happens every time you place a block. So if we go into this last place scoreboard, as you can see, I have this value right here, which is the tick where I last placed a block. So basically I have this scoreboard right here, the time scoreboard, and as you can see it keeps ticking up. So basically this is the time in ticks since the canvas has been created. So as you can see, if I create a new canvas right here, it's gonna restart to 0 and keep on ticking up. Now as soon as I place a block, so I'm gonna go into the into this, no, not this scoreboard, oops, I'm gonna go into this scoreboard. Now as soon as I place a block, my value on this scoreboard is gonna be replaced with the value of time at the time where I placed the block, basically. So that is gonna keep track of the timestamp of when I last placed the block. Now you might say, what do we need that for? Well, if we take the time we are currently at right now and we subtract the last place time, we're actually gonna get a difference. And then we can check if that difference is greater than the cooldown, and if that's the case, then I'm done waiting and I can start placing blocks again. So we're just basically doing the difference from the current time and the time I placed the block, and if that difference is greater than a cooldown, then that's great, I'm done cooldowning. And you may say, Nico, that's super complicated, why did you do that? Why can't you just, have a scoreboard with the cooldown in ticks, and then just decrease that score, the more time you wait, and then when that score is 0, the cooldown is over. Well, the problem with that setup is that it actually needs the player to be online. So with this setup right here, I don't actually need Nico the Pro to be online. I could actually be on cooldown for like an hour, and I could leave, and then join back in an hour, and in an hour I'm gonna calculate the difference again, because this timer is gonna keep on ticking, and I'm actually gonna know that I can place a block again. So this is why I set up the cooldown in this way, just so players can leave the game, and the cooldown is gonna still keep on updating, and they're gonna know when they are ready to join back and start placing blocks again. Now, explaining this with my voice, it's cool, but doing it in code can get a little bit more complicated because Minecraft must be Minecraft. So all of the code that I explained is actually being executed right here. So as you can see right here, we're actually adding every single tick 1 to the time. This is how we are actually, increasing the current time. And this value actually gets replaced, gets reset every time we generate a new canvas. We didn't see that function yet. So what are we doing? We're basically taking the value of last place, which if you remember, is the value of time whenever you place the block, the value right here. and we are copying it over to this other scoreboard. You may say, Nico, why are you copying the value over? Well, because I need to do something with this value, and I don't want to lose the original value. So we are taking this value, and as I said, we are subtracting it from the current time. Remember, this is happening every single tick. So we are doing subtraction from the current time and the time I last placed the block. And we are setting this value on the temp last place. So in fact, if we go to the temp last place, you're gonna see that it's actually showing the difference. As you can see, it's showing the difference between whenever I place the block. So if I place another block, it's gonna be 0, and that's the difference in ticks from whenever I place the block. So this means I placed the block 100 ticks ago. I placed the block 200 ticks ago, which is 10 seconds ago. Okay, great, so now that we have the difference, we have to compare if the cooldown is greater than that difference. So we have this other scoreboard, which is called the cooldown, which is actually gonna keep track of, okay, how much time I have left waiting, because we also wanna show that on screen, as you can see. So the cooldown is a really important thing, and we need to have it. So if we go right here, as you can see, we're gonna have the cooldown exactly. So now, in order to show the cooldown on screen, I need to show it in seconds, and this is why I'm dividing the cooldown by this cooldown constant, which is basically 20, because I'm basically taking the number of ticks and dividing it by 20, because there are 20 ticks every single second. So that way we get the number of seconds, and as you can see, every time I go in cooldown, I'm gonna get the number of seconds that I need to wait. The way I actually get that value is by taking the cooldown, which is equal to how much time I need to wait. So this value is actually set right here, and right now is 10 seconds, which is 200 ticks. So I take this value, which is like the maximum cooldown, and I add it to the temp last place, which basically represents how much time has passed since I placed the block. And this value is negative, so I'm basically adding to something positive, something negative. So I'm taking 10 seconds and I'm subtracting how much time has passed. And this is why this, counter is counting down. So as you can see, it goes from 10, 9, 8, because every single tick I'm taking 10 seconds and I'm subtracting this value right here, which gets bigger and bigger because the difference between whenever I place the block and what time it is right now gets bigger and bigger. So this is how this logic works. It's pretty convoluted, but the intuition is really simple, and so this is what these 5 lines of code do. And then actually checking if the cooldown has passed is really simple. We just have to check if the scoreboard right here is greater than 0. If it's greater than 0, I'm still on cooldown. If it's not greater than 0, then I'm not on cooldown anymore. And that's exactly what we're doing right here. We are checking if the cooldown is, less than 0, and if it's less than 0, then we're gonna replace our hotbar with all of the items we can place. Also, if it's less than 0, we're gonna reset our title bar, so we're basically gonna reset the action bar, and we're gonna remove the in cooldown tag, so this way we know that the player is no longer in cooldown. So all of this stuff gets executed as soon as you're out of the cooldown. Instead, if you're ever in cooldown, it's gonna do 2 things. First, it's gonna clear your inventory, and also it's gonna run a title on the action bar, which is gonna say how much time is left on cooldown. And naturally this is generated using an external website, but all that is doing is basically, writing on screen the score of the cooldown objective for the current player. And that is how this works. So as you can see, if I reload, it's just gonna say cooldown and the number of seconds left. Okay, this was a lot to go through, but this is how the basic logic works. And naturally, in order to make this run, even when the player is not online, I had to make this convoluted system. But it still works. Anyway, now the only function that we still need to see that gets executed every tick is the draw function. And this is actually really simple. Basically, all that it's doing is it's getting the position of this area effect cloud, which basically represents the canvas that we're placing. Every time we place a canvas, we're actually generating an entity which keeps track of where the canvas is. And basically what this function is doing is every single tick is making sure that the canvas doesn't get corrupted. So as you can see, if I try to break the canvas, it's gonna refill it back with white concrete, so that it doesn't go away. Naturally, if you want the base to be a different block, you can change this with whatever you want. And as you can see, if I reload the function, it's gonna change it to black concrete. Or it's not gonna do anything, because why? Oh yeah, because I have to regenerate it. Whoops. So it's making sure that the base doesn't get corrupted, and also it's setting on top of the base a bunch of barrier blocks. So as you can see, there are a bunch of barrier blocks right here, so that the player cannot directly interact with the canvas, basically. Then another thing that it's doing is it's taking all of the blocks that are on top of the barrier blocks, and as you can see, it's taking all of the blocks that are on top of the barrier block and it's cloning them onto the canvas. So this is what the code right here is doing. As you can see, it's taking all of the blocks on top of the barriers and it's cloning them down onto the canvas, but it's only taking some blocks, it's not taking all of the blocks, it's only taking the blocks in the palette. So that's why the tag needs to be there. As you can see, if I try to place any other block as soon as my cooldown expires, if I try to place any other block, it's just gonna disappear, it's just gonna move, but it's not gonna be placed downwards because that block is not in the palette. And this is the code that is actually making those blocks disappear. As you can see, it's filling all of the area with air, so as soon as I place a block, it's gonna disappear. And this is basically all that the draw tick is doing, and just with these 4 lines of code, I can actually have a working palette. This first line right here is just making sure that the area effect cloud doesn't despawn, because when this duration parameter goes to 0, the area effect cloud is actually gonna despawn. So what I'm doing is I'm constantly changing this value to be this really high value, so there is no way that our canvas is gonna despawn. Okay, great, and now the last function to check is actually the generate place function. This function only gets executed on player command, so it only gets executed whenever an OP player actually tries to generate a new place. So what does this do? It goes to the position of the old place, which, if you remember, is marked by this area effect cloud, and it actually fills it all with air. So as you can see, it's removing all of the previous place. After it's done removing the previous place, it's actually gonna kill the entity which was keeping track of the place, and it's gonna reset the cooldown of all players. And it's also gonna reset the temporary variable of all players, because, you know, it could be messed up. And then we are finally summoning another area effect cloud, which is gonna take the place of the old area effect cloud. So we are summoning this entity which is gonna have the place tag, so we can recognize it from other area effect clouds, and it's gonna have a really high duration, even if this is gonna get changed by this function anyway, so it doesn't really matter. Anyway, once we actually generated the area effect cloud, we can start filling the entire area with white concrete, and the reason we are doing it right here too, because as you can see, we are doing it here every single tick, but the reason we are doing it right here too is because the player could be placing the canvas inside the dirt or inside the terrain. And if they do that, we actually wanna replace the terrain with white concrete. We don't want the terrain to remain. So that is why we are doing this right here. It's just so we can manipulate the terrain. Because as you can see right here, we're only replacing the air blocks. We're not replacing all of the blocks. Alright, and then at the end, we are setting the cooldown constant to 20. I don't know why we're doing this. Doesn't actually need to be done here. This can be done in the load, because this is not going away anyway. This constant is always going to be 20, which is because it's basically the constant we divide for in order to, get our time in seconds. So, this can be easily put right here. So yeah, now you know how this works, and let me just reset the scoreboard so, we can test it out one last time. And as you can see, this is how it works, and now you can just create on the canvas something neat. Oh, also you can change the size of the canvas, I forgot. So it's a little bit hectic to change the size, but it's doable. What you have to do is go in the generate place, and as you can see, you see where all of these 50s are? You can actually just go and do, I'm just gonna do it with rPlace. I can do rPlace, I can look for 50, and I can replace it with any other value, like 10. And now I can make a really smaller canvas. So as you can see, I'm replacing it with 10. And then we can also go into the draw tick function, and we also need to do the same operation right here. So we have to take all of the 50s, and we need to replace them, not right here, not like this. So we take all of the 50s, we replace it with 10, and as you can see, if we reload now, it's gonna break a little bit because, this canvas is not gonna be counted completely, but if I generate another canvas, it's gonna be fine. So let's generate another canvas, and yeah, okay, it didn't completely remove the last one because, I changed the code, but, let's leave, let's go away, let's generate another canvas. And as you can see, this canvas is much smaller, so, you can tweak the size of the canvas this way. But now let's just change it back on both functions so that everything is fine. And alright, oh my gosh, okay. And there you go, that was it. I hope you really enjoyed this video and this tutorial. Also, that terrain is really weird. What is that? Is that plains? Oh no, oh my gosh, yeah, and the lags begin. And the lag begins again. Oh no. Oh, what is this structure? This is super... Oh, it's the amethyst thing, which is like peeking out at the top. Okay, yeah, this is not supposed to happen at all, but okay. Anyway, that said, I hope you really enjoyed this tutorial video. I wanted to make a really simple tutorial on how Datapack works, but also do it in an interesting way, where we're doing something relatable and something that all of us participated in, which is the Reddit r/place thing. So I wanted to do this cool tutorial. If you want to see more tutorials, maybe even more advanced, let me know in the comments. And I'm sorry, I've been busy with my schedule and I didn't do many videos lately. But yeah, I will try to upload some more. It's a little bit hectic right now, but you know, I'm gonna try to bring some more content for you guys. But you know, until then, I'm gonna see you guys in the next video. Leave a like if you enjoyed this one, and thank you ever so much for watching to the very end. And I'm gonna see you guys in the next video. See ya!